So ellipsoids are what we get when we've got a situation where all squared terms are present. So we have an x squared, a y squared, and a z squared. And when they all have the same sign, so not all positive or all negative. So that means that we're studying level sets of a function which is a quadratic polynomial in 3 variables that looks like this. So all three x squared, y squared, and z squared are present, and they all come with a positive sign. And so if you're given something that where they all come with a negative sign, you can multiply through by -1. And similarly, when you go to look at a particular level set by fixing the value of f equal to a constant, then you can divide through by the value of that constant to make sure that the equation that you're looking at always looks like something set equal to 1. So if we were given something that looks like this, then I could divide this whole equation through by 3, and I'd have a 1 over here, and then I'd have like a root 3a and a root 3b and a root 3c over here in each of these. But since those are just constants, I'll just take that to be my new a, b, and c, and I have an equation of this form. So that's what I mean, I can sweep it into the constants. Okay, so let's go about understanding how to sketch this guy based on traces. So if I do x equals 0, then I'm going to be looking at something y over b squared plus z over c squared, squared equals 1. And so then in the y-z plane, I would have an ellipse here that intersects z equals 0 when y is equal to b and minus b. And it and I can see that just by, if I put z equal to 0, that term drops out, right? So then I'm going to get y equals b and minus b are going to be the solutions. And similarly, if I put y equal to 0, then that part is gone, and I have that it's going to cross the vertical axis where y is equal to c, or sorry, where z is equal to c and minus c, and so then that gives me an ellipse. Yowza. That looks like that. And if we do y equals 0, then we'll have x over a, z over c. And so let's see, so y is equal to 0, so that's going to be this one that looks like x and z. And x will cross at positive and negative a, and z will still cross at positive and negative c. And we'll have some ellipse going that way. And if we take z equal to 0, then we have x over a, y over b, both squared, equal to 1. And so now we're looking at the xy plane. And so we've got a and minus a, and b and minus b. And so we've got something like that. So if we try and now assemble all of these together, and now if I haven't drawn these all exactly the same size, they'll look like absolute garbage. So expect garbage. Yep, see? Garbage. Come here, you. Let me. Woohoo! Okay, balance it out there. And grab that last one. Oop. And make it a bit smaller. Ah! Come on, you little jerk. Hold still. Okay, there we go. Ta-da! It's an ellipsoid. Let's get some shading going on in there just to make it all like pretty like. Okay, hold on. Maybe that actually didn't really work so well, but ta-da! It's an ellipsoid. It's a hairy ellipsoid. Apparently he's grown a blue beard. All right, I should have quit while I was ahead. All right, so there's our y-axis coming out that way, and our x-axis and our z-axis, and yeah, it's an ellipsoid. Okay, and so you can see that if we go back to this original defining equation right here, if I choose large values for the constant, then I get bigger values for the ellipsoid. So the level surfaces of this function are going to be oh god, that's really bad, I apologize. The level surfaces of this function are going to be ellipsoids.